right, today we're going to start at example 5. Did you find that one? Example 5, so day 2. And this is a lot like what we were doing last week, except instead of square roots on the sides, or whatever roots, we have them in the other form, which is the fractional exponent. So you want to isolate this fractional exponent. What are we going to do first on both sides? Take away your 2. We get 2x to the 3/4 equals 8. Now my next step is to get rid of 2 to the 3/4. So that's a power. And what we want is that exponent to turn into 1. So what we're going to do is we're going to raise both sides to a power that will make 3/4 turn into 1. What do I multiply 3/4 by that equals 1? 4/3, the reciprocal. If you multiply reciprocals together, they equal 1. So if I do it to one side, I have to do it to the other side. So we're raising both sides to the 4/3 power, so we get 2x to the first power, basically. Now 2x to the first power is just 2x. So now I can solve for x easily. But on the other side, this is what I'm talking about. We can do this with no calculator. This would be something that you need to know how to do without a calculator on the test for the non-calculator section. You're going to take 8. We've already done it. You're going to reduce it down to a power with an exponent. What is 8 equivalent to? Two to the third. And that is still to the 4/3 power. When we did this before, now what did we do? You're using the wrong word, but multiply. You're going to multiply straight across. You're going to multiply straight across, not cross multiply, but multiply straight across, right? So we will have 2x equals 2 to the, now I probably would reduce this in my head before writing the next step, but I don't want to assume everybody can. So I got 2 to the 12/3, which reduces to 2 to the what? 4. What is 2 to the 4th? Oops. So how do we get x by 5? Divide by 2. How do I know that's correct? Now, if you're allowed to use your calculator, you can check on your calculator, but you got to still write down on paper what you're typing in. So if you're checking with your calculator, you're doing 2 times 8 to the 3/4 plus 2, and hit enter, and it should equal 10. So take a moment and make sure everybody knows how to type that in your calculator. It does work. We do have the right answer, but make sure you know how to type it in your calculator. Come on. You charged it. It's good to go. I just want to practice typing in your calculator. Make sure you know how to type. Make sure it equals 10. And if not, ask me so I can see what you're typing in. So your 3/4 is only under 8. Okay. See how my front keys are? Yeah. Then are yours. See, I want to make sure you know how to type in your calculator. I just corrected a mistake there. Okay, next is x plus 30 quantity to the 1/2. Did I write that? What did I have written up there? Did I have 3/4 square with that? I have to make sure. You know what? I could make a mistake. Yeah, 3/4. Oh, you just typed it wrong. Okay, so to both sides, I'm going to raise the power to both sides. As long as I do it to both sides, what do you do it? Square. So then x plus 30 equals x squared. Now if I have an x squared in it, I'll have to solve it different ways. I want to make it say equals 0. Probably want to try factoring first, maybe quadratic formula. Also, if I want to try factoring, then I want x squared to be positive. So I'll make this side say 0. Move everything to the other side. So we're going to have 0 equals, I can factor that, x and x, plus or minus. It'll be 5 and 6. Which one would be minus? 6 would be minus. We solve by setting each equal to 0. We get 2 answers. If you get 2 answers, you gotta check both answers. The evidence on your paper is just that you checked them. You can check them on your calculator if you want. So I'm going to do negative 5 plus 30. So the 1/2 has to equal negative 5. So add that together, I get 25 to the half. Has to equal negative 5. You type in 25 to the half, it does not equal negative 5. So negative 5 is not an answer. Type in the other side, we do 6 plus 30 to the half has to equal 6. So 36 to the half, which is 6. So that one checks. Only answer is 6. So the same stuff that we did before, only this time it's exponent instead of square root. So there's 3 you try. You try. We'll try the next card. If you check on your calculator, it's okay as long as you write down what you typed in, so I know what you typed in. it seem easier than yesterday or last time? No opinions? Make sure you should check. And then if you're using your calculator, just write down what you typed in for your check. I mean, it's still not going to work, but. Yeah. So that 8. Factor that in. That's the next step. That's all we do. Multiply. It makes something silly. The next chapter that we do, it would be very helpful to know faster what's 2 to the third, what's 2 to the fourth, what's 2 to the fifth. It's going to make the next chapter so much easier. Next chapter, we're doing something called logarithmic function. Ever heard of? Yeah, still first time I'll ever see it. Okay, got it? Anybody have questions on these? I have all the answers up if you haven't noticed anything of the answers. So if you know a lot of your 2s and 3s, 4s, 5 powers, 10 powers would be helpful to know, like what's 10 to the third? So, 1,000, yeah. You know those? So it'll make next chapter much easier for you. But if not, still make a chart of them. Okay, we've got one last section to cover. If you were working ahead because you're like, man, this result is explaining this so well, I get it, I'm going to work ahead. I actually changed the very last question. So don't do the last question if you're looking at it. All right, the last kind is we're going to be solving inequalities. So these are not just equal to, but we're going to have numbers that are less than or numbers that are greater than. So there's going to be more than one answer for these. And because there's going to be more than one answer, we also have to keep in mind something very important about when you take the square root of a number. Well, that's if I put it in myself. Am I putting in the square root? No, it's already there. So since I'm not putting in the square root, it's not plus or minus. It's only whatever sign is here. Because I'm not putting the square root in myself. The thing that I have to think about when there's a square root is that the square root will give me a positive number. The square root is going to give me a number that is greater than or equal to 0. So when I see that this is a square root, the very first thing I do is I make 2 equations. The first equation is as is. The second equation is we use the square root exactly how it looks there, x minus 1. And I say that answer has to be greater than or equal to 0. It has to be because it's a square root. If you do the square root of 25, you would tell me 5. You wouldn't give me a negative number unless there was a plus or minus in front of it, which there's not. So if it's a square root, we have 2 cases. There is a restriction on the domain where x's or the square roots have to be greater than or equal to 0. Now we're going to solve each of these separately. I'll solve this one in blue first. It's pretty easy. How do we solve this one? Same as equals. How do we solve this one? Square both sides to get rid of the square root. We get x minus 1 greater than equal to 0. We add 1 to both sides. X has to be greater than equal to 1. That's one of my pieces about my answer. Has to be greater than equal to 1. And on this side over here, we're going to solve that just like we were the other day with the equals, only we're going to keep the same inequality. So what are we going to do both sides? Just like you do the equals, what do we do with both sides? Not yet. We have to get the square root by itself. So divide by the 3. So we'll have square root of x minus 1 less than equal to 4. So I just bring down that statement equality. Now we square both sides. So we get x minus 1 less than equal to 16. And then we add 1. X is less than equal to 7. So what we do is we have two pieces of information for this answer. And our answer has to incorporate both of these. That's not my final answer. My answer is going to incorporate both of those. So to help me figure out my answer, I'm going to visualize it. I'm going to put it on a number line so I can figure out the answer. Now, I don't know if you noticed I used two different colors. My first answer, x is less than or equal to 17. So I go to 17, less than or equal to is closed dot, less than or equal to this way. There's less than or equal to 17. Second part is x is greater than or equal to 1. So here's 1. That's also a closed dot, but it's greater than or equal to. So I'm going to go this way. Now my solution is where both of them are, where both colors overlap. Can you explain to me where both colors are? Duncan, do you know where both colors are? Between 1 and 17. Does it include 1 and 17? So to do that, to write our final answer that says it's between 1 and 17, and it includes 1 and 17, you're going to write x, and you're going to put x is between and equal to 1 and 17. See, I wrote it in between. I put my smallest number first. I put my biggest number last. X is greater than 1, but less than 17. And if you look right above it, the endpoint 1 and the endpoint 17 are right there. X is in between. All right, let's do another one. Did you do those before? The answer's scary? Yeah. Algebra 1. We do it in geometry.
No, it's pre-calculus.
Now, in pre-calc, we are graphing like circles with less than or equal to and problems. Word problems. Okay. Next one. We first noticed, is it a square root? Is it a square root? Somewhere in the problem. Square root? Yes. So I need the second part over here that says, also, whatever's under the square root has to be greater than or equal to 0. And I look over here, it says that. So I need that second part. I'm just going to solve the blue one first. It looks really easy to solve. X has to be greater than or equal to 0. Square both sides, x is greater than or equal to 0. On the other side, we're going to do what first? We're going to add 4 first. It's just solving like regular equations. We're trying to get x by itself, only it's square root of x. So now I have 3 square root of x less than or equal to 12. Divide by 3. Square root of x less than or equal to 4. Square both sides. We have x less than or equal to 16. Put both pieces on the graph. So less than equal to 16, close that, less than. Greater than equal to 0, close that, greater than. When you look at the picture, do you see how it overlaps in between? So you write 0 less than equal to x less than equal to 16. Yes? No! You can get it. People that last year skipped stuff though had trouble. Because not all of them look like that. Not all of them look like that. Let's look at the next one. Is this the square root? So we need the other piece that says square root of x minus 5 has to be greater than or equal to 0. It does not matter that the first line is greater than, the second one is still greater than or equal to. It's always that. And we'll solve each of these. This 0 side, square root side, you get x minus 5 greater than or equal to 0, so x is greater than or equal to 5. There's my first side. Second side, I'm going to divide by 2 first. And then I'm going to square both sides. Get x minus 5 greater than 9, and then I add the 5, and I get x greater than 15. So do we have to do the number line every time? No. Can you figure this one out without the number line? I don't know. My first part is that it's greater than 14. That is an open dot at 14, and it's greater than. The second one is at 5, a closed dot, and it is also greater than. So where do they overlap? Where are they both? Aiden?
Greater than 5.
Both colors over here?
Oh, greater than 14.
Greater than 14. Are both colors at 14? No, because the 14 is an open dot, both colors are not, so it's only greater than, it's not greater than or equal to. So since they both overlap at greater than 14, that's our answer. So no, you don't have to do the number line if you can figure it out, but like when they start changing and going different directions, that's where it gets confusing. Almost done, almost done. One more, 2 more. That last one's the one that I changed. You're going to want to change that. All right, number 11, is that a square root? 11a. Square root, so we have to have that second case, but it's just square root of x. So x greater than or equal to 0. There's my second one. I'll solve this side. I'm going to add 3. 2 square root of x greater than or equal to 6. Divide by 2. So x is greater than or equal to 9. That's my second part. I did it really fast, sorry. So we can look at our number line. We have 9, closed dot, greater than. We have 0, closed dot, greater than. Where do they overlap? At 9, equal to 9, and then which side of 9? So x would be greater than or equal to 9 would be our final answer for that one. Okay, the last one, I added a negative sign in because I wanted to review something that you probably haven't thought about in a very long time, and it is in the homework, so I wanted to review it, see how I added a negative sign in. Okay. What are we going to do first? First, we're going to say, is this a square root? It's not a square root. So if it's not a square root, if it's not a square root, it's an odd root, it's a cube root. If it's not a square root, I don't need the second part. Because I can have square root of negative numbers and equal negative. Like I can have that. So it's all, cube root. So it's only when there's square root of fourth roots that you need that second case. So we're just going to solve this one. What are we going to do first to solve it? What do we do first? Times what? reciprocal of what? Of negative 4, which is what? Negative. Or you can say instead of multiplying by negative 1/4, I'm going to divide by negative 4. That sounds a little bit easier, but it's the same exact thing. So we're going to divide by negative 4 both sides. But there's a rule. When you have an inequality, if you multiply or divide by a negative, you have to switch your inequality. You have to switch it. Remember that rule from my algebra 1? You divide or multiply by a negative, you have to switch inequality. So now I have cube root x plus 1 greater than negative 2. Now what are we going to do? Kids like cube root? You can stand up if you are falling asleep. Cube both sides. We get x plus 1 greater than negative 8. So x greater than negative 9. There, I don't need to draw a picture, so I don't have two pieces. It's just that. Yay. So just pay attention to those rules. If it's a square root, you need the second piece. If you're dividing by a negative, you've got to switch the sign or you're going to get the wrong answer. There is our assignment. It is in the book. The rest of the week, we will review and take our test. Yay. If you want to take pictures of the book before you leave, go get one. What did you say? February is this week. Wait, if you're taking a picture, stop. 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 I just want to stop the video, that's all. I don't want to get a picture.